everyone, my name is Glenn. I'm doing our project here with Nash. Our project is called TrueShot, and basically what it is a automated designed t-shirt cannon that can be placed into any basic football stadium that can deliver t-shirts and other prizes directly to a fan's seat based on kinematic equations. Nash and I first came up with this idea because we're both in dynamics currently and have been using a lot of physics and kinematic equations, and we thought it would be cool to implement them into MATLAB code. In particular, we thought one interesting place we could implement this is in during football games and basketball games where prizes and t-shirts are delivered kind of erratically and sometimes don't reach the higher level seats. Whereas if there was a designated cannon that could deliver prizes and shirts specifically to different kinds of people, it would greatly improve a fan's experience. So that's kind of our inspiration around it, and now Nash will talk about some of the code and how we got our project to work.
This is Nash Taylor now speaking, and this is a topic of our code. It ended up being a lot simpler than we originally thought to do the actual coding portion, just because most of the coding was just making sure that we eliminated possibilities that would normally give an error. So the code begins with you need to input the section, row, and seat number in order for the code to find exactly where the t-shirt cannon needs to shoot, and then begins by just eliminating all section, rows, and numbers that don't actually exist. Initially, our stadium that we chose had 22 different sections, but that would have been way too much, so we eliminated it to just 4, which we titled the VIP sections. So we had to choose our code so that it would get rid of all other sections and have them output errors. Then the code goes into once an actual section, row, and number have been selected and verified, actually the math of calculating where and how fast the t-shirt cannon needs to shoot. As far as calculating the actual angle required to be inputted into the t-shirt cannon, we just used basic trigonometry using sine, cosines, and tangents. Calculating the actual velocity required a little bit more work. We just used the basic kinematic equations to find these things. We began by finding the things in the y direction, then plugged those in still in variable form to the x direction. After we did this, we then had an equation for velocity that could be plugged into MATLAB. Once we finished with our code, it was then time to actually run it. So as you can see, the code has now been completed, and it's now time to give it a test go. We'll start with just doing a section that should give a correct result, just something random. And as you can see, it outputs an angle and a velocity required. However, if we were to change the row to something not possible, such as 55, which is greater than 50, the possible number of seats, it says error, not possible seat number. Again, if we were to try this with something such as 40.6, a decimal, it gives error, not possible seat number, because there are no decimal seats. This works for all 3 sections, outputting the correct thing of either not possible seat, not possible row, or not possible section. As far as actually using this code in the real world, it would definitely have to be modified to fit other stadiums. The stadium that we chose to use was just a simple one that we designed, and also this code only accepts a small amount of sections. If it wanted to be used for a real-life football stadium, a lot more geometry would be required, and a lot more information about the type of stadium and all dimensions would be necessary. Overall, our code ended up working the way we wanted it to, which was very pleasing, but it wouldn't be as effective in a real-world situation.
We'd like to thank all of you guys for listening and thank Mike for a great year. We encourage you all to go out there and try and catch some T-shirts at a real football stadium. Have a good rest of your year.